You should be able, you should be able to see my screen now too, correct?
Yes.
Okay, perfect. Excellent. Get rid of this stuff. Okay, so if you're still opening files, don't worry about it. Keep doing what you're doing. I'm just going to talk about the op sheet a little bit, starting with the op 5 sheet. That is literally just showing the stock setup. So as you can see, we're working the 1.5 inch bar. There are some notes in the bottom left-hand corner that mention some material removal notes and the minimum bar. So we have a 3-inch length of the bar, but it says use a minimum bar length of 4. And what that basically tells me is they're going to basically have 3 inches sticking out of the vise with 1 inch in the vise for material holding, which is good. So with that information, we know how to set the work holding up in that and in the vise shop setup and the stock setup. So that's good. The front of that stock piece, I'm sorry, the front of the part is going to be where Z00 is. And again, op 5 just shows an offset on the right-hand side of 20,000. And that's just letting us know and the operators know that we're going to pay $20,000 to basically qualify that surface. And then we'll set 0. You also have the overall length there. That is 1.660. And you'll see that note number 5 actually calls out a cutoff position of Z minus 1.805. So what is that? That's 145,000 more, something like that. So that's basically for pacing on the back end again if we do that. I normally just, especially for this, there's not really that much to it. We could just pace that off at 1.660 and not worry about all that much. Okay, I'm not going to worry about it, but as long as you're aware, if you've got a back surface that's important and you're worried about it being really straight and square and everything else, spacing it isn't a bad idea. So that's just op 5. That is not a machining sheet that we need to worry about. We're not going to do that in a separate op. The first sheet that we're really concerned about is going to be op 10. Okay. So you'll notice that op 10 consists of all the roughing and finish machining all the way through the middle groove, and then it leaves the back half for the next operation. So again, this has all the pertinent dimensions on it. Most of it is going to be used for inspection purposes. For what we're doing, it's just kind of letting us know what the order of operations are. As long as the model is correct, these dimensions are going to be where we are. We can do anything really separate. It does, so if you read note number 1 on it shows you where it's on the groove, right? Or no, where note number 1, the upper right hand corner by the stock, it mentions the 20,000 to remove. No big deal. We already saw that in op 5. Note number 2 mentions set the stock 3 inches from the front jaw. So again, we already covered that. Note numbers 4 and 5, just basic, let us know where the stock is and let us know where the tolerance is for that corresponding thread. No big deal. We're going to use the same roughing tolerance as the last time. So we're going to leave 3,000 on the wall, and we're going to leave 10,000 on the OD on the side. So it'll be 20,000 total. And we'll use the same nomenclature. So it'll be W.010 in the note, the same that we did last week. Again, that's following Tom Miner's invention from the day. And we're going to machine that pretty much exactly the way they do it during the day. There's only a couple different options. We're going to use the same. Op 20, again, is just a part flip. When we get to the stock flip, we'll talk about the parameters again, and we'll do that one as a group as well. So op 20, it's basically you're going to be finishing the threaded area and the relief area in the back. I believe at this point the grooving is already done, but we have not done the drilling. So flats in that grooved area will be on op 30. Okay. Or op 20, I'm sorry. So that's all the Z-axis stuff. Oh no, I'm sorry, it was op 30. Op 10, op 20, op 30. I might even just combine these. I don't know why they call them out separately. I don't think you don't need a separate toolpath group for this. You know what I mean? It can be done all in the same toolpath group. I think they have it broken out this way because they want you to inspect it, you know, after you do those features and then put it back in and then do the drilling. So what we'll do is we'll actually set it up so that we only have the two operation groups. Does anybody have any questions so far about what we're looking at part-wise? Well, it kind of makes sense. Okay, good. So we're going to start by loading the part in as usual. I got a blank Mastercam folder file started. And again, I'm going to go and grab the machine group first before we bring the part in. So what I want to do is go up to machine, lathe, and we're going to take the SC20 here at stick, and you can use default at home. You should have the same exact toolpath available to you under default. The only thing you have to do is look at the tooling. If you're doing this from home, we'll have to use different tooling, or I'll send the library to you, Matt. So again, like we normally do, you know, make sure we're in D plus Z plus. Bottom left-hand corner tells you that. Ignore the X, Y, Z in the middle. Always look to the bottom left because that's your WCF moment. I know I say that every week, but it's good to keep that in mind. And then I'm always going to go and check my planes and make sure I'm where I need to be. Currently, I am not, right? So when you load the tool path, when you load the machine group in, it doesn't automatically set plus Z and plus Z as your active. Your construction plane is there, but your WCF and tool plane is not. So we want to throw those down immediately. And we want to remember to check in with that periodically, right? We don't ever want to accidentally throw a tool path on top or anything because it'll screw up it'll screw it up when it goes to backplot it. And now once we do that, we can go ahead and rename toolpath group 1 to op 10. We're going to start with that. And now we're ready to basically load in our solid parts as usual. So since we have this file started and we have some parameters set, we don't want to do file new or file open. We want to do file merge. File merge will just bring in the part without starting a new file. And you want to go ahead and grab that Rev2 part file. It should be in your week 11 folder. And when you download it, it should be car Pully V1R2. Hopefully I put the right one up there. I believe I did. So when we open that, it should come in, right? So it's asking, there's more than one configuration. We want the first one. We don't want the light print. We want the first one, I believe. So I'm going to click OK, and then it should come in that way, the correct way. We'll talk about the orientation of the flat in a second, but for now, let's click OK and just drop that solid model in space. We'll set the origin, and then we'll rotate the part to get the flat in the proper orientation, just for, you know, to match what the print says, just for ease of use. So we can cheat. Instead of using dynamic translate, we can just look at the part at a little bit of an angle, kind of zoom in towards the front of the thread, and then we're going to go to transform, and we'll use move to origin. Move to origin is the 5th toolpath from the left. We'll left click on that. Make sure you get the center of the bottom of that chamfer at the end of the thread. Once you do that, you can left click and your part should shift to the left. I'm now going to orient the part going right click top just to get the part to align to the axis. I'm going to double check my plane and make sure, see that, so when you right click and hit top, you see it moved. So if you do like to use that like I do, you got to remember to reset that plane. So go back to planes and just make sure your plus D and plus Z are active there. I need to find out why right clicking sometimes moves it and sometimes doesn't. If I was smart, I would do like, there's a thing here called G view. I could probably do just plus D plus Z and that would get me to the same orientation, but just be careful when you're doing stuff like that. So the same thing we did last week, you know, if you look at the op sheets and everything, the flat and the drill are facing towards you on the print. It doesn't, that orientation does not matter, right? Because it's symmetrical. They're two 180-degree features apart from each other. But I do like to have all that stuff facing me when I'm working. It doesn't affect the tool path at all. It just makes it easier to see from the front anyways. So what we're going to do is we're going to use transform, or let's just do, let's do dynamic, which is, it's good for us to keep practicing that. So we'll do a dynamic move. We're going to select the solid part. We're going to hit end selection. And now we want to rotate without moving the origin, okay, because we already have that set. So what that means is we want to click the 0, point on the part that we just established and rotate around that. That way we won't accidentally move the part out of the axial plane that we're working in already. So I'm just going to zoom in and make sure I'm getting the center of that same, the bottom part of the chamfer we were talking about. The axis of rotation that we want is the axis between Y and Z. We're going to click that line segment that's red. And then we can, at this point, we can go positive 90 or negative 90. It doesn't matter. Like I said, it's all symmetrical. I'm doing a positive 90. You're following along 100%. I hit enter once to see the preview and hit enter again to set the command and be done with it. So we'll click OK on that. I'm going to go ahead and orient back to my G view so I can see my D plus Z, and then you should have the flat and the drilled hole facing you when you reorient the part into the right, into the axial view. That is the last thing you have to do as far as manipulating the geometry of the part itself. We have not renamed it yet in levels, so I do want to go in there and do that now before I forget about it. I'm going to go into levels, and the name of this part is op 10. Well, it's all the ops really, so I don't really care. We can just call it mousetrap car Pully rev 2. If you're only going to have one solid part, I'm not worried about you having to put the op 10 in front of it because that can be confusing too. You expect to see more than one operation in the levels, and you really don't. So let me just double check everybody's stuff. Yes, mousetrap car. Fully read. Everybody's getting pretty good. This is part of it now. It's pretty easy. But the orientation. No, that's okay. You can ignore that. What you're looking at is down here. So if you go to plane, set this to your B plus Z plus. So just hit the equal button. And then click on the G view. So we need to do that in 90 degrees. Okay. Yeah. You can click the part, you're selecting the part. Yeah. Make sure you get it right. Okay. So now, yep, there you go. And that's nice. Good. So now when you click on that, you can hear the whole thing. Okay. So with our part established, we're going to go ahead and save the file before we do anything else. So we'll do file save as. If you don't have your file structure set up yet, go ahead and make a week 11. This one's a little bit easier because there's not going to be any SolidWorks stuff to hand in this week. You may have noticed it was there earlier, but I deleted the assignment out of there. So this assignment is only Mastercam related for the week. So I'm just going to rename this, whatever I want here. Now that we've saved it, now we can go and establish our stock. Everybody should know now where to go for that. We go to Tool Tabs. We go to Properties under the Machine Group, and then we go to Stock Setup. Always work from the top down so you don't miss anything. So we're looking at Stock Plane first. Right now, the default is top. We want to change that to our lathe plane, plus D plus Z. We want to go into the stock properties. And now we're going to bring up the op sheet and just confirm our values. We'll both these on the screen here. Feel free to go ahead of me if you want to, if you know what we got to do already. Go. All right. So again, so looking at our Ops 5 sheet. Oops. That's not going to keep both up. So the OD of the stock is 1.500. The length, technically, this is 3, okay? The minimum bar length is 4. So you could do it one of two ways, right? You could set the length at 3 and then add a margin. I'm just going to set the length at 4 and leave it alone like that. We'll use that bar length, and then we will set up the chuck to be 1 inch up on that piece of stock. And then that will give us our 3-inch stick out, like the print calls for. Again, I don't really like messing around with the margins unless you really have to. This isn't usually easier. So 1.5 OD, 4-inch length. Z is going to stay, actually Z needs to be modified, right? So who remembers what the print calls for facing? 20,000, perfect. So we're going to go in the positive direction. So we're going to add 0.020 to that Z position along the axis box. And when you hit tab, if you have your view positioned correctly, you'll actually see the stock shift out. That's perfect. Once you do that, you can click OK there. Now we're going to go to the chuck jaws. We're going to click on Properties. We're going to skip geometry and go straight to parameters. Next, under position, we're going to click from stock. And it's going to grab our 1.5-inch diameter that we already have. You'll see that our grip length is coming from the back of the bar. So that means if we want a 3-inch stick out on a 4-inch long bar, the grip length should be 1 inch. Now you'll notice, maybe this is the reason why some of this stuff is done a little bit differently. So if you see the Z position, it's a Z minus 2.98. So because of the way we did it, it looks like that we're short that 20 thousandths because of that offset. Now we can accommodate for that by just adding a grip length of 1.02, I believe, and that will get us to, or other way around, grip length of 0.98. And that gets us to our Z -3. So that's probably why they do that a little bit differently during the day. As long as that Z -3 is correct, that's the important part for us. Because what that means is when the operator's on the machine, he's physically going to measure that 3 inches with a scale, right? So if we don't have that set up right, and that was 2.98, it would actually be off when he went to go measure it. He measured it at 3, and then if he didn't cut off on the part or anything like that, it was screw up. So we make sure that D is -3 inches. Looks good to me. We're going to click OK. And then we'll click OK again. And now I'm just going to zoom out and kind of preview what my jaw looks like. It's pretty good. Plenty of clearance in the back there. If it were me, I would actually choke that up a little bit. But we'll leave it the way that the print calls for. Again, the more stick out you have, the more TIR and run out issues you're going to have when you're turning parts. So that takes care of everything on for op 5, the setup stuff. So again, op 10 calls for roughing. I'm going to ask you all to work on this independently for about 15 minutes. And I'm just going to go over what the parameters are right now. So your first operation is going to be spacing. At this point, everybody should be very proficient with that. Your second operation is going to be roughing. I want you to rough the OD of the part past a certain value of this groove here. So, you know, if you're machining to this chain point, I want you to go past that point by a little bit, just to make sure you have a nice edge in the back there. It's not super required because we're not parting off at that location, but it's still nice to kind of go a little bit farther past that. Remember, you're not going to do anything with this groove until we do the dynamic grooving. So we do not want to dive into that part when we're finishing or roughing. We're going to ignore the groove for now. That's separate. You're going to leave 20 thousandths on the roughs, 3 thousandths for the wall. You're going to finish that same profile, and then you're going to thread. Okay. And I will definitely help you while you're working on it. I just want to see where we are kind of independently and see where our strengths and weaknesses are. So go ahead and start with the facing, do the roughing, do the finishing, and then pause, because at that point we're going to do the grooves together as a group. Okay. So we'll go till 6:15 if we need to go that long. If we finish faster, that's fine too. And I'll actually do it right along with you. Don't forget to put your comments in. And when possible, tell the operator how much material you're removing or how much you're leaving for the next pass. It looks like we may not be able to use the solid model as the chain. It looks like it's busted. So we're going to have to do a turn profile. So I will walk you through that just in case, because we haven't done tons of that. I'm assuming everybody's gonna get the same error.
I got it on the tool library.
When you go in there, it gives you a 55-degree OD right should come up when you face. If it's showing you boring bars, you might be in the wrong command by accident. Are you in facing?
Yeah, I got it.
Okay, yeah, that's fine. Does it call out a tool for facing? Oh, gotcha. Yeah, no, that was fine. Yeah, that's a rubber too. Okay. So I think that has that. I got to figure out why it does that. I think it's because it's an older model. Maybe I need to open it in a newer version of SolidWorks and resave it. It's not going to kill us because we know how to do this turn profile, right? But it is an extra step. You know, last week was nice because it worked really sweet. So let's go into levels, and we're just going to pre-make a level for our wireframe. So I'm going to hit I'm in the levels tab. I'm going to hit the plus button, add a new level, and we'll call this I don't know, Pully wireframe, something like that. It becomes active when you create it. So you just check the green, make sure the green checkbox is next to the number 2 or whatever number you made it. So now we're going to go over to wireframe, and inside of wireframe, or no, the transform, or where do you go? I forget. Wireframe. There it is. Thank you. Under shapes. Yeah. So about halfway into the middle of a screen, we want a term profile. We're going to select the part, and we're going to want to do a slice, I believe. I always get this wrong. Let me do it first before you guys hit OK. I'll do a slice and see if that's the right one. Yeah, so slice is the one that I want. That's the one that I like. So again, you'll be in term profile. You'll select the part. You're going to do method slice and click OK. So when you turn the solid off, you're going to have a blue wireframe of the OD of the part. I'm going to change my color so I can actually show you what we're doing and we can see it. So I'm going to change my color to something easier to see. Now, I'm hoping that the fact the solid's not funky, so I'm hoping that's not going to screw up our C-axis stuff. But we won't know until we get to it, so we'll find out.
Hey, Sean.
Yes.
Where was the slice?
If you go to the wireframe tab, and then you're looking for the shapes subgroup.
Yep.
It's basically under where it says lathe, turning, and milling. You kind of see where my mouse is now, by any chance?
Yes.
So you're looking for turn profile.
Yes.
So when you left click on that, it's going to ask you to select the solid part.
Mm-hmm.
And then you're just going to go to the left-hand side and change the method from spin to slice.
Gotcha.
And then you can click OK.
All right. Thank you.
And you're welcome. If we had done spin instead, we would have gotten some extra geometry, like the vertical lines where it came in, and sometimes that confuses the chain. So that's why I like to do the slice instead. Once you do that, you can carry on your merry way. So you'll be doing roughing, and again, just make sure that you unselect the undercuts. You do not want to allow undercuts, and that will allow you to bypass all of the features that you don't want this tool to dive into. Although because this thing is C-plane, wireframe. Now let me specify my endpoint. This is a little odd. So it's like if I'm trying to partial chain this, it's still taking the whole chain. Normally it comes in exploded. Oh, let me try turn from. What's that?
You click on it, the pilot thing.
Yeah.
It goes right up.
It does, but we were going to try and stop a little bit further. You know, I mean, we weren't going to go all the way down across, but we can do that though. That's certainly not going to hurt anything, so we might as well. So it's going to look a little bit different than the op sheet. So for example, let me show you the op sheet here. Oh no, you know what? It does have us go all the way to the back. Anyways, so that's fine. We're good. Yeah, so you're going to chain it so it looks like this. And then you're just not going to dive into the back. That's fine. Oh no, it was U. 20,000 U, and then W was the wall, 0.003W. There we go. Starts to get confusing when you use these different numerical call outs because it still uses X on the Mastercam stuff too, so it's kind of strange. So that's gonna be 10. That's gonna be 3. Now on the lathe rough, that is, since we're doing it like this, that's where we kind of want to have a little bit of an extension because we're going to part off back there. So we don't want to stop right at the edge of the part. So when you do your lathe rough, make sure you go into your lead in and lead out. And we're going to do a lead out extension. A lot of the time people accidentally put that in the lead in tab because they do it real quick and they forget they're not in the right area. When you go right into lead in and lead out, you need to switch sub tabs and go to lead out, and then you do your extension. And I'm just going to do 200,000 just to make sure it's just plenty of room back there to clean. And actually, I don't know what I did, but didn't actually extend my toolpath. Why not? Extend 0.2. I know why. So because that last chain is going down, it's extending that last chain. So I wonder if we need to do exit amount in this case to do that. 200. Yeah. So here's a quirk that I may not have taught you about the system if everybody wants to look for a second. So normally when we chain, right, if we had chained this normally, we probably would have stopped like here when we're chaining, right, or the bottom of this chamfer or something like that. So because the last chain that we have is going like this, when you go to extend your tool path, even though you're not turning this, it's looking at it. So when you do a lead out extension like this, it's actually extending this last line. It's not going in the Z. I've noticed this before. It's not going in the Z axis, it's going in the other axis. So in order to get around that, what I do is I change the exit amount, and that modifies the end of the tool path, but only in this cut direction. Okay. So again, I'll set this exit amount to 0 just to show you what I did, right? So now we're back to normal here. The first thing I did was go into lead out and extend by 0.2, right? This all should look good. But because of the way the system chained it, you see how that it doesn't actually do any extension here. We're still lined up with the end. So when you bump into a situation like that, if you can't or don't want to change your chain, the other way you can modify this is by changing your exit amount. So if I do 0.2 in the exit amount, that does what I want correctly. So kind of remember that both those things, the exit amount and the lead in and lead out, do the same function. But depending on how you chain it, you may have to do one over the other. I think it's because the way we did the stock flip, yeah, what do you want to call it, the term profile. I wonder if I did a spin. Yeah, it gives you the vertical lines, right? And that always screws us up too with the chain. So it's, I equate it to like a CAD function. So like this, you almost want this line to be exploded. You don't want it to be all one thing. But I don't know if there's a way to actually explode it the way I'm talking about it. You know what I mean? If you do that, it acts like a spin. So if you try to click it, it gives you the spin profile. I don't know how to change it so it only gives you the lines. Yeah. It might have something to do with the way the solid is right now. But let's try. So if we try to do just curve on edge, you see how you can't get the top. You only get these lines here. Curve all edges. So if we do curve all edges, and I just delete this, let's check it out. Yeah, so even curve on all edge only gives you this. It only gives you this stuff. It doesn't give you anything else. It's okay. What we're doing is working. I'm a little bit concerned about about what's going to happen when we go to do the C-axis stuff, but that's all right. We will figure it out when we get there for sure. I'm just going to close the door so we're not hearing the back. Actually, finally. So we're a little bit over because we were talking about that. So I'm on my finishing, so hopefully you guys are close. Let me just do the finish pass real quick. And then I'll do a walk around and see where everybody is. Make sure to change your tool when you do your finish pass too. You don't want to use the same one. You want to use something closer to a 35-degree, a finishing tool. And on this one, we're going to have a little bit of an issue because there's no way to do
the extend. Oh, you do adjust contour. I don't suppose it's gonna let me do it here. Of course not. So that is a pain in the butt because the lathe finish, there isn't that same option to do the extension in the main. I don't think you can do like the negatives in the Z. Probably gonna yell at us. Oops. Oh, you can do negatives in in the stock to leave on Z. I wonder if that will do it. No, actually, so what did that do? That doesn't start it? It actually moved in the front, so no, we don't zero there. We'll leave that little lip. I'm not going to fight it. We talked through why it's doing that, so I'm not too concerned. Matt, were you able to get the finishing? You're working on threading?
Yeah, I'm working on the finishing right now.
Okay. So we're still doing good. Everybody's still in the same spot. What are you trying to do now? For facing? Yeah. Well, you shouldn't use like anything. You just do facing. So sometimes you get into a command and then it minimizes and forget you can't really see it. So hitting escape issue, all that stuff. Good. I just selected the left click and then delete it. Yeah, it won't let you right click delete those, but you can use the delete. Yeah, I don't know why that restriction is there, but they're going to be reviewed. Take it out, okay? Okay.
You said that we're not going to get that over.
So yeah, actually on the finishing, good question. Yeah, but then you go, you want to zigzag. Yeah. We actually should do that profile separately. So go ahead, you make it so fast to chain up. So just, yeah, it shows it as a chain, but I'm not. It shows all the way, but it doesn't get that going all the way. See if you can get that, chain independent. Right, yeah, right. Chain independent. We may have to mess around with that a little. Yeah, that's what I was talking about. So that's okay. So brushing and finishing. Well, no, it actually selected the whole thing now, so these are okay. But you're right, it's not doing exactly what you want. Yeah, we don't want to do a center part though. No, what our issue is going to be this area here, because we do want to undercut that with the finish tool, but we can't chain that independently the way it is now, so I'm going to have to look around. I mean, we can obviously draw that geometry if we want to, which is probably what we're going to have to do, bypass that. It's a good exercise in troubleshooting, but it probably is something is not correct here.
What's the OD one, the viewer?
So U is for the OD, so U would be 20, and W is standing for wall. That's how I remember that. I don't know if it stands for wall or not, but that's right. Yeah. Get the roughing and the finishing done, and then we'll do a couple of things together as a group to fix the problem we're having with the chain.
I remember having this happen before, but I can't remember how we fixed it. Oh, I think I know why now. What the hell? It might be a planes issue. Oh, we can do that. That's not very exacting, though. Ooh. I'm not sure exactly what I was picking on. We're just gonna draw a couple of lines to deal with the relief in the back of that thread. So we'll give it 5 more minutes. Oh, I turned the solid off. So if you go to level, no. Yeah. Yeah, just go ahead and solid. Yeah. You want remaining stock, all right. Yeah. For this one, it doesn't matter as much because it's your first pass. Okay, go back into your plane. Go back to full tab. And just hit that. It may not want it because the program will change over. Okay, got it. On the next one, you're gonna want to recognize the left stock, but on the first pass. So you got the running part. So U is 20,000. Well, so this is a note, so I don't know if you're reading that, right? Yeah. So U is the moniker they use in the comment. So U is just the numerical code they use for stock to leave on diameter. So when you see U, that means it's the total amount. So when you say U of 20, it's an X of 10 because X is the radius. Yeah, 0.020. And then W of 0.03 is the wall, so that'd be the V off. So when you go in there, yeah, so your X is 10. 0, 3, 0, 0, 3. Yeah. Yeah, no, you're right, that's correct for now. Yeah. If you run the back plot, you'll see that the tool is lower than the line. It's showing you the center line of the tool radius, so the tool itself is actually a little longer. Be slower down. Yeah. So you're good for now. Hold on for a second. So if you do that, it's going to try and dive in here. Yeah. So you want to go on your cups for now, and then we're going to do something better with that. So I'm saying, we'll do the bench passes. Yeah, but make sure you're not on your cups. first instinct was right, because the chain's not working correctly.
Just draw a line across the top, right?
That's what we're gonna do, yeah. Not across the top of the groove, but we are gonna draw, I gotta figure it out when we all get to it. We'll do it as a group and decide how we wanna fix it. Just wanna make sure you guys are all set. Okay, hold up on the threading for now. Okay. So we're all at the same spot. So let's I just want to talk through this. So the issue we're having with the chain, whether it's related to the solid or not, we have to figure out at least one of two things. When we're chaining for the finished path, we normally would be trying to get into this relief. You see this triangular relief behind the thread, kind of an awkward looking thing here. We can't machine this with the finished pass without turning undercuts on. But if we can't isolate the chain back here, we can't turn it on without trying to dive into this groove either. So to your point, one or two things, right? We try to chain it across that groove so it ignores it, or it follows that line, or we could just do a separate tool path and just machine this area here separately. You know what I mean? Well, but we have to draw. So I'm saying we could just draw it, you know. But what I want to get, the point that I want to make though, is that I don't think we can get snaps here, which we can't. So I don't know if we can use, I'm going to look and see if we can use the solid rather than the wireframe that we made. So if we had the solid here, it looks like we can snap to these endpoints. You see that?
You try to chain them on the solid?
It won't let you do it. That's why we had to bypass it, because if we try to chain it, it says it's missing the parasolid information, which is annoying as hell. But let me just double check and see. I didn't make it level for this. So, and I don't think it worked anyway. Oh no, it did. Okay. So let's do it this way. This is the easiest way to do it of the two options that we have. So as a group, let's go to levels. We're going to make a new level. And again, this is just a good troubleshooting step. You know, you get used to doing stuff like this when you have problems with the file. I'm going to call this thread relief wireframe. And again, if you're not doing this as a group, you know, this would have taken us yourself two minutes to do and just bypass it and do this, right? It's just a little bit difficult when we do it as a group. So thread relief wireframe, I'm going to make sure that's active. I'm going to turn my my pulley wireframe off, level 2, turn my solid back on. And now I can use the quadrant points on the solid basically to draw that triangular relief there. So you can watch me first if you want and then follow. I'm going to click the top of the chamfer where the thread relief is, where it starts in the back. So I'm going to click there. I'm going to drag that down and snap to the bottom of that triangular area. That creates my first line. So 2 left clicks creates the first line. Now I'm going to left click the same spot, making sure I get the endpoint and not anything else. And then I'm going to walk all the way up to the bottom of that like radius in the back left-hand corner there. Okay. It's hard to see it right now until you turn the other stuff off. So I'm going to click OK and turn my solid off and my levels. And then you'll be able to see those 2 lines that we drew. And I'll change the color so you can see it.
No way you can do the radius.
I imagine we could. I was thinking about it when we were talking, but I don't know how easy it's going to be. We could probably go, let's see, if we go to wireframe and we do a arc 3 points, if we could get the 2 endpoints of the radius and then the quadrant. So let's try it. So I'll do arc 3 points. I'll get, normally you click the 2 endpoints of the radius, and then you specify the diameter. Yeah, I wonder if we could tangent. If we're doing a 3-point, it doesn't look like we can put any dimensions in here. Let me see if I can do it a different way while we're talking. So let's do circle edge point. Let's see what that does. That lets us put a radius in. So what if we do this? Let's try that again. So let's find out the radius, actually, the radius value before we do it. 15,000. So I don't do this, so bear with me. 2-point tangent, maybe 0.015. And then we go. Yeah, it's not going to let me do points. It's looking for surfaces. Let's leave it as a tool nose for now. It's a little bit shallower. You know, the drawing or the saw is a little bit shallower than the tool nose radius that we're using, but you're still going to have a radius in the back there due to the tool when it goes. So let's leave it like that for now. There's probably a way to do it, but I don't want to spend the next 15 minutes trying to figure it out. You know what I mean? Maybe when we finish this as a group, when we get, because I really, the meat and potatoes of this lab is the C-axis stuff, so I want to try and get to that. So if you turn off the other 2 levels and you have number 3, this should be what you're looking at, these 2 lines here. Does everybody have that without an issue? Okay. So with that selected, now we can do a finished tool path on those 2 lines to get that relief machined in. So I'm going to go back to tool path, and this is going to be an extra one. So tool path number 4 is going to be a finish. And I'm just going to select that chain that we created right there. And that allows us to do a partial chain, no problem, because it's not one solid line like the other thing. So we'll click OK. I'm going to use the same tool. My comment is just going to be finish thread relief. And really, this is a terrible thread relief anyway. And then finish parameters, you don't need to do anything except to make sure that plunge parameters were allowing plunging in both directions. Otherwise, it'll just skip right over the bottom of that again. And obviously, we're not going to have a sharp edge in that corner either. We're going to have the tool nose there. And hopefully, when we do this, we're not going to have interference, and we are. Ignore it. We're going to have to probably just change the way the lead-in's working, that's all, yeah. It's not really a collision, it's like coming in and touching where we already machined on the thread. However, we can change the lead-in and lead-out. So instead of the lead-in, sorry, let me go back a little bit fast. So in that lathe finish, I'm gonna go back into parameters. I'm gonna go back into lead-in and lead-out. And this is where that collision's happening. So in the lead-in, there is a straight entry vector of a 0.100,000. If we change that entry vector to like straight up and down 90 degrees, it'll come in from above the start point instead, and it won't touch over here like it was calling out earlier. So what I'm doing is changing the lead in. I'm not changing the length. I'm just changing the angle of entrance here. So now it's going to come in from straight from the top, And that should get rid of that, oh, it's going down bottom here. Ignore that. Bum, 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 bum. Wrong direction. So we want to change it so that it's negative 90 degrees instead of 90. It's kind of silly because that's true. So if you think about the tool point, I've never actually explained this, I don't think. So the tool knows it's the center of your compass. So technically, if you're centered here and you're going up, it's actually you starting lower, you're starting below. We turn it around and go negative 90, your tool knows it's going to go down this way. So I did that the wrong way. So we'll flip that to negative 90, and that should get it started above tool path. There you go. Much better. So that gets us our thread release. I'm going to back plot mine just to kind of look and see if you look at the overall totality of the tool paths that we've done so far. Turn my levels from that back on. So we've had to do a little bit of troubleshooting on this, but I'm not heartbroken about that. That's how you kind of bump into new solutions for things. If we have time at the end, I'm definitely going to revisit that chain and see if we can do something different with that first roughing chain. But so I'm going to save this. It's been a little while. And now we can go ahead and do the threading real quick. And we've all done that before, but we can walk through it kind of as a group again. Referencing the pulley sheet for the drawing, we see that it's a 1/4-20 thread again, which we're used to doing. That's a fairly common thread. We use that all the time. So we're going to go to thread. I'm going to use the default TO505 bit for now, and hopefully there won't be any interferences. There shouldn't be. For a comment, I'm just going to say thread 1/4-20. And again, in thread shape and thread cut, you're picking from, or mostly in thread shape, you're picking from a table, so it's pretty easy to input all this stuff. I'm going to go from select from table and change it to 1/4-20. If you don't see it right away, like if you're in a different, which I think we are, UNRC, that's not what we want. I think we want UNC, UNF, unified. So that's the third option for the drop down. So thread form should be unified UNC, UNF, and then you can scroll down and find 1/4-20 UNC. Once you select that out of the thread table, it automatically inputs all of the data for major, minor, lead, and all that stuff. The only thing we don't have is end position. Start position of 0 is good because that's where our WCS is. Our end position, we're going to go ahead and just select, I don't know, let's select the bottom of that thread release. So the intersection of those two lines that we drew at the very bottom. You may not need to use those lines. You can probably use the solid to get that point. But either way, you want to click that edge. And it looks like that should be negative 0.383. And I'm just going to check my numbers here as far as the thread goes. So, yeah, so if you look at the thread note on the blueprint, it says 2 times 0.383. So those numbers match. We're in good shape. Now, there is another table that we have to go into on the right-hand side called allowances. I'm going to be honest with you. I'm not sure if this affects the code or not. Judging from the major and minor allowances when you click on these tables. They're very small. So for example, if we select our quarter 20 thread again, it's 0.0011. It may have something to do with the number of passes. So let's say that the number of passes is adjusted so that it falls inside of that tolerance. It could be something to do with that for the most part. When we go to thread cut parameters, I'm just checking in here to see if there's anything we have to do anything with. The only thing I normally change in here is that you see the acceleration clearance. We've talked about this before. Some machines are better than others at getting up to speed before the tool engages the material. So if you're not at full speed or full feed rate when you start, your thread can get screwed up because it's running at a very set rate of motion to create that thread pattern, right? You're basically zipping across it and you're only cutting a small area as you go. So sometimes you may want to extend this acceleration clearance and give it more time to ramp up and get to that speed. And so 0.2 inches, that basically means that it's going to start the thread cut feed rate about 1/4 of an inch off the part before it engages the material. Okay, and that's going to vary again by what your machine can do. Number of spring cuts of 1. That's basically the same thing we have when we're doing sidewalls for milling. A spring cut is basically a repeat of the last depth of cut, just in case the tool moved or the part moved a little bit. It's just kind of just touching it again, just to make sure it's getting that full material removal. Everything else on here is stock, and we can leave it alone as is. So we'll click OK there. And just see what that looks like. So you can see that our thread feed rate starts 0.2 off the part. So that's roughly, 1, 2, 3, 4 thread pitches. Then it engages the part, and then it's stopping dead right at the point that we selected. My only concern with that is, the back of that last thread may not be fully formed. Normally, I wouldn't want to stop right at the end there. Normally, we'd have a straight relief back there. And again, you're not going to see the thread form. You're just going to see the cuts. So you got 1, 2, 3, 4, 5. So there's 5 cuts. And you'll notice that as it gets to the bottom of the depth, you'll see that the cut increment is actually smaller. And again, that's the machine calculating the number of passes, and based on the clearances and things like that of the thread, you want to take less material towards the end so you're not accidentally overcutting. It's more accurate if you're taking less material. You're never going to want to just take the full pass right at depth, right? Because your thread will never work. The clearances are pretty tight on stuff like this, believe it or not. So that's good. So if you have your thread, we can save that. So you see where it says end on the left-hand side? Click on where it says the end button, and then click on the bottom of the relief. It should be -0.313 or 383, something like that. Yeah, it probably said -1 before, right? So that's the default. Yeah, so we had to just change that length. That's all. You're welcome. All right, so now we're going to do that dynamic groove, and that allows that we have to chain that groove. So if it doesn't allow us to chain it, we may have to draw this. So let me see if we could figure this out. As far as when we go to start the chaining, follow along with me. Don't try it. Just watch what I'm doing, and because I may need to troubleshoot a couple of things here while we're walking through this. It should be easy, but it's not going to be. Dynamic rough is what we're going to try and use. And let me actually just open up my reference file because I want to just make sure I do this right the first time. Which one do I want? This one. Just bear with me 1 second. Yeah, so if this doesn't let us chain it the way we need to, that's going to be a bear, because then we will need to figure out that radius, how I get those radiuses drawn in there. Matt, are you following along okay? A couple of hiccups here and there.
Yeah, I'm doing okay. I'm right where you are right now.
Okay, perfect. Excellent. Okay. All right, so I'll try to do this the way you're supposed to, and then if it doesn't like us, then we'll have to play around. So dynamic roughing is the new tool path that we haven't seen yet. And basically, actually, let me give you an idea of what it's supposed to do actually before we talk about it. So if I turn the level on over here. So this is what dynamic roughing looks like. Rather than plunging the groove, we're actually going to get, again, I call it a peel motion, right? Kind of just like milling, right? You know, we talk about dynamic milling, it has the same kind of thing. So you use a grooving tool, but what happens is instead of plunging, the tool comes in and kind of scoops like this, okay? And the only thing you have to keep in mind is that you have to use a radius tool that's going to be able to form the bottom of this, right? So it looks big on screen, but that's only a 50,000 tip on there. And that allows us to fully form the bottom of this. I forget what the radius is on the bottom of those grooves, but it's not much. 10,000, right? So 0.05 is exactly half of what the radius is, basically. Sorry, yeah, 100,000. Okay, so that's the gist of the tool path. And I'll show you the chain too while we're here. So the ultimate goal is to do an easy chain, right? We normally would pick the top radius here, do a partial chain, come over here and pick that one, and it'd be done, right? Now, I can almost guarantee you now when we go to do this, it's probably not going to let me do that because of the way this is set up. Let me turn this. Well, so we do this, right? So unable to extract, I get that. All right, so we turn that off and put this on. It's not going to let me select this. Now, I was screwing around with something. So endpoint, it's not letting me do that, but it did let me do dynamic last time. So when you click on the start and endpoint and go dynamic, it asks you to select an area to move, so we can do that. I can dynamically move this, but you'll notice I can't get a snap point, so you're almost kind of guessing as to where the hell you're stopping, which is not good. You don't really want to guess when you're doing blade work. I mean, I can zoom way in and kind of just eyeball it like this. I'm just going to see if it works, right? So there's that. And then I can go back and do dynamic again, pick the start of my thing here, and then do the same deal. And again, I'm just doing this to see if it actually works. I'm not entirely convinced it's going to. But then, so let me just see if I can find the tool. So it's T1313 in that library. I don't know if we have the same, if this is the same library. Doesn't look like it. Because T1313 here is a flat groove. So let me just, again, you're watching me, right? So don't worry about doing this yourself. I'm going to go into what library is this? Oh, it's in the ST20 library. So why is it not showing up for us?
T1313 should be a full, it's not a full radius tool. So this has been changed since then. So I'm going to go into lathe inch and see if I can find something similar to that. So we're looking for a full radius tool. It's kind of hard to see it. I don't know if that helps, not really. So that looks like it's similar. An R of 01, T4444. Let me just grab that and see what it does. And I'm not going to change any parameters. I just want to see if it actually works. Button tools. That's not a button head tool. I wonder if there's a way for me to import this out. Bear with me 1 second. No. Tool manager. So I'm going to try and export this out so we can grab this button head tool. Save to library. I'm going to put it on my desktop. If this works, I'll put it on the server so that everybody can grab it. Did it go where I want it to go? Yeah, there's that. This is turning into more of a headache than I thought it was going to tonight. I can do this again. Let's just do that for now. Oh, that worked the way it's supposed to. Okay, so let me go back and adjust the, I'm going to go back and adjust the chain. So I'm just trying that dynamic out because I don't think I've ever tried to do it like this. So I'm curious to see if it works. Because the top of these two towers, I'll call them, are already machined. You know, if we start and end a little bit farther in or out, it's not going to kill us. So if that does what I want it to, well, yeah, but it's still got the rest of the stuff selected. So, and we need to rechain. We need to reverse that. No, not reverse. Let's change side. Reverse. And then we want to change the side because we want the down arrows into the groove like that. Let's see if it works. Nope. All right. So now we're back to having to draw this. Or maybe we can actually go into curve on edge. Can we use, no, I won't let you use the chain that we have here. Can we break these? Did that work? Okay, the break worked. So let's try that again. So And I'm gonna have to go back and figure out what exactly I did. So inside a wireframe, in the modify area, you see these trim to entities, break to, divide, stuff like that. Those are ways that you can modify line connections, basically. So if I want to break, let's say I want to break these, break at intersection. Let's see if I can just select the chain to break, right? And now, if I just click the radiuses, let me do it. All right, I did break two pieces before. So that's the entity you want to break. And now it says indicate break position. So what I want to do is I want to try and break it at the radius. But again, it's not giving me a snap point. I can click somewhere close to that, and that breaks it. So now I can select the entity over here, and again, click near the radius, top of the radius, click it there. And then that at least isolates the groove for us. You see that there? Don't bother doing that yet until I figure out this actually is going to work the way we want it to. So I'm okay with that. Now I'm just curious to see if, let me just regen these. I'm curious to see if that's going to fix the chaining issue with this now. And if it does, then we'll walk through it as a group and we'll actually break the chain this way. I'm just going to delete this. That looks a lot better. I need to check my plane and make sure I haven't screwed that up first. And I did, that's why it's giving me that error. I'm gonna have to redo this real quick. Yeah. So I didn't check to make sure that I was in the right Z plus plane. That's why I was getting that stock error. It wasn't seeing the remaining stock. So now that I've got my WCS C and T here, I got my chain the way I want it. Now we should be good. I got my fingers crossed here. T plane. I also had to go and Mickey Mouse my tool in. I'm not going to change parameters right now. I just want to see if it works. Okay. Everybody got that? It worked with you, no problem? Are you kidding? What did you select the chain like I did, or did you just? You did, and it worked for you when you did that, the dynamic? Maybe I didn't have enough room for it or something like that. That's funny though. So you did dynamic and you moved the arrows to like halfway in between the two stanchions. Okay. So probably when I did that dynamic, I probably didn't have enough room. Like I didn't go far enough out to the side, maybe. So for what you got, don't worry about doing this whole rigmarole that I just did. You can leave it alone. But for those of us who have not gotten it yet, let's walk through the break thing, because that's actually a good thing to talk about anyways. You know, I'm going to undo all this and go back to the start. And what tool did you use though? I'm curious. You found a button tool? 1313. Okay. Okay. So let me delete this. And undo until my break is back. Oh, it's not going to let me redo it. Now my file's all screwed up. I'm going to open. Hang on a minute. No, save. There we go. All right, so this will be fun. Okay. So for everyone who still needs to get this chain correct, this is a good troubleshooting exercise. So I'm actually kind of glad when stuff like this happens. So we have a set of tools inside of wireframe related to trimming and breaking wireframe entities. Okay. So what we're going to do is we're going to use the break two pieces command to separate a chain out. Okay, so we have a full line that we want to basically turn into parts that will enable us to chain an area that we'd like to do. So I'm going to go into, again, wireframe, and all the way to the right, we have trim to entities, and then we have break two pieces. We want to break two pieces. The tooltip is break an entity at a specified point. So we'll left click on that. Our entity is going to be that entire unexploded line that we had from when we did the wireframe originally. So when you left click on that, it selects that entire chain. The second point that I want this to select now, if you read the tooltip, says indicate the break position. Okay. Now it's not letting us snap to endpoints. So what I want you to do is zoom way into one of these first radiuses here, the one in the front. And we want to break this somewhere after where that radius starts. Because if you remember from when we were machining this last, the finish tool path did not do anything with that radius. So this grooving tool has to do it. So we want to make sure that we're out past the endpoint of that radius. So I'm going to left click somewhere to the right of that. You'll see we get a little crosshatch mark. And then you can see now we have two separate entities there after you left click. Now we're going to zoom out and do the same thing to the other side. We're back to select an entity to break. So we're going to select the back half of that line. Now it asks us to indicate the break position again. And we're going to go ahead and do the same thing. We're going to click to the left of that back radius. We're going to get that second crosshatch mark there. And now after doing that, when you bring your mouse into the groove area, you'll see that we now have an independent chain in the middle, and we've broken that out from the rest of it. Now we also could have done that same thing for that back thread release too if we wanted to have, right? The only reason why we didn't do that here is because drawing the radii in here would have taken us a little bit of time to figure out. And this was just something that came, that worked out as we were doing it. So now we're going to go ahead and save this. Hit enter to exit that command first, or escape. And then just confirm that you still have that line segment the way we did it. And then we'll hit save. Because we were messing around with that chain, you'll see that a couple of these tool paths broke. At least on mine it did. So I'm going to regenerate those. We may have to do something with this. I'm just going to ignore the warning and let it regenerate, and then we'll have to check these out after we ignore these warnings. Lathe Finish is really unhappy with us. We may have to repick the chain. Yeah, see, because it went to the, it went right to the break. So now I got to rechain everything. Not a big deal. So go back into number 2 and number 3 and just rechain so that the it looks the same as it did before. For some reason, it defaulted to that back break, and that's why it's throwing an error. But again, if you just left click the front of the part and the back of the part, the way we normally would have anyways, it finds, it walks past that break, and then you can just regenerate it normally. Okay. So let me hide the toolpath. And now we can actually explore the new toolpath like we wanted to in the first place. Is everybody okay with fixing those last two toolpaths? You're still working on it? Okay. So I'm going to go to turning, and then we're going to go to that dynamic that we've been playing with, right? Dynamic rough. And this time you can follow along because it's going to work for us this time. So dynamic rough. Again, our chain is going to be that broken segment that we created using the break two pieces command. Doesn't matter where you click, but I normally like to click the beginning, near the beginning. And you'll notice that it'll grab that whole chain. So you have a green arrow on the right, red arrow on the left. I'm going to click OK on the chaining. And now I'd like to use the same tool library. So if we don't have to. So what tool number did you use? Sorry. 1313. T1313. And that was in the ST, okay, and that's in the ST20 tool library. Okay, so Matt, you may have an issue because I'm not sure you're going to have something like this on
Yeah, I don't
hand
see anything.
with a full rad.
Yeah.
Okay. I think I can actually think I can throw a file in the Zoom. So let me do that. Let me see if I can just, because what I did is I saved that tool independently. Yeah, let's close this for a second. I actually saved this tool independently too. I might be able to just throw this up here. Give me 1 second. So if I can add a file, otherwise I'll just email it to you.
Mm-hmm.
Yeah, I'm going to email it to you.
Okay.
All right. And that. All right, where are you? Oh, MMM, that's right. MMM. So basically what this is, Matt, I made a quick little tool library from here and just saved that one tool in it. So what you'll do is just download that file and throw it on your desktop real quick. Okay. And then when you're inside a Mastercam, you can just go to select library. You go to change the library.
Right.
Just go ahead and point it to that one I just sent you, and that tool will be in there.
All right.
For us here in class, we're going to use T1313, and our comment is going to be rough through, rough the groove. And let me just see, I think we are leaving some for finish. Yeah, so U is going to be a value of 0.040. So U 0.040. So that's the bottom of the groove. And then the wall is 0.003. That'll be 0.003. So we're leaving 40 thou on bottom and 3 on the sides. Now, for the dynamic rough parameters, we're using, let's see, this tool full radius is what? R.059. Yeah, it's the same. Okay. So in dynamic rough parameters, it's easier to use, for me, it's easier to use the step over percentages as a total amount and not as a percentage of the tool, right? So if we want a step over of just say 200,000, that's our depth of cut. We want to put that in the right-hand box. So I'm going to change that to 0.020, and the percentage is going to change accordingly, right? So that's like a 33% of the tool. And then for a tool path radius, that's going to be basically the size of the tool nose, the radius. So we're going to change that to 0.05. We can just round. So we're using that. Then we said the stock to lead in the X, which is the U, is going to be half that U value. So it should be 20 thou, right? Because that's on diameter. So if we want to leave 40, our X is going to be 20.020. And then again, in the Z, we're doing 0.003. Okay. The pathway that I showed you was a zigzag, so it's going to go back and forth, back and forth, back and forth. We could also do one way, you know, so we'll just kind of go, do a cut, sweep, lift up, sweep again, lift up, sweep again. And then I don't think we need to do anything with the plunge parameters or anything like that. Right now we're allowing undercuts in both directions, so that should be fine. And then I'm just going to check the lead in and lead out and make sure that's not going to screw us up. So the lead in is going to come in straight across the top, which is fine with me. I'm not really too concerned with that. The lead out is going to come back and up at a 45-degree angle away from the chuck, and I'm also fine with that. So hopefully, with fingers crossed here, I'm going to go ahead and click OK, and we should get our tool path here. I need to regenerate mine. It's thinking. Whew, there it goes. Now, don't be concerned when you see that tool path, because you're going to see it's offset a little bit, and it's kind of like the tool path actually looks like it's cutting into the side of the groove. When you back plot it, the actual tool nose is going to be in the right spot. It shows up a little bit weird because of it's showing you like it's showing you a different point on the tool. Hopefully that's so when you slow down that back plot, you're going to see that the tool nose should actually be line on line. What a pain in the butt. So again, we're going to back plot that slow. Looks like it's doing what I want it to me. That 3,000 looks like a lot when you're looking at it like this, but I guess this part's kind of small. So, but yeah, so we're down to actually touching the walls. Every cut you're seeing here is 20 thou. And again, when you get down to the bottom, you should be a certain distance off of the radii and stuff like that too. So this should be, so there's your 40 thousandths right there too. Matt, how's yours turn out? Okay?
Yeah, doing okay, but I kind of missed the parameters a little bit, but I can review it later.
I can go back through it too. So it's actually easy. So if you have the tool if you have the tool selected, here's your note. So it's rough OD, and we're going to leave 40 U, which is on diameter, and 0.003 W, which is on the wall.
Yep.
And in dynamic rough parameters, we're just doing a 20,000 depth of cut. So next to step over, without using percentage, you want to specify 20,000. You type in 0.02 in the right-hand box.
Right.
And then for toolpath radius, I just put in 0.05, which is supposedly the size of the ball of the tool. Right. But it's not coming back at 100%. So, but I did round it a little bit, so that's probably why it's not. And then X and Z correspond to those other numbers we talked about. So in the X, it actually should be, I screwed that up, it should have been 20.02. And then in the Z, it should be 3,000, 0.003.
Got it. Okay.
And then you do want to make sure that inside of plunge parameters, you're allowing plunging in both directions. I believe is the best way to do it.
Okay.
Otherwise, if you had it, if you had set to 0, it wouldn't go in at all.
Right.
If you do a second or third one, I don't think it matters. Yeah, it doesn't matter because there's nothing in the sidewall for it to plunge into, so it's not really doing anything. If there was geometry in the sidewall you didn't want to touch, then you'd want to change it to the third one. Okay, awesome. So in order to finish this, we just want to do a straight cut, basically straight down and up. So we're not going to use dynamic. Dynamic is mostly for material removal, removing a lot of material. Now we can do a regular groove tool pass and just kind of finish that area up. So we're going to go to lathe grooves, which is just the second option in the second row. If you got to do that, you got to expand the gallery and go to regular grooves. I'm not sure we've done a lot of this either. There's a couple ways to define the groove. You can do points or you can do a chain. Since we have that nice chain set up for us, I'm going to go ahead and use chain as our selection method. When you click OK, it's going to ask you to select the chain, and you should be able to go to C plane and then grab that same broken area that we just did with the trimming commands earlier. So we're going to grab that. We're going to click OK. I think we could probably use that same tool. I don't see why we wouldn't. Yeah, so use the same tool we just did for the roughing. So for us, it's that T1313 or the tool that I sent Matt earlier. Our comment is just going to be finish the groove. We can go to groove shape parameters. Nothing to really change in here. It's going to be a straight up and down. That's basically what our tool is set up for. So it's going to come down straight and go up straight. That's all fine. For roughing, we want to reset all these values so that we're not leaving any material. Or actually, we just turn rough off. I'm sorry. That's the easiest way to do it. We'll turn roughing off. We'll go to groove finish parameters. And although it looks complicated, the only thing I'm really concerned about is the direction. I don't think it really matters all that much, to be honest with you. If we leave it clockwise, I'm just trying to see what I don't want to do. I want to do it all in one pass. That's what I'm looking for. Let me just double check and see. I was hoping we could just scoop in and scoop out, because the way this looks right now, it's going to come in and go down to the bottom and then come up and then go over and come back down again. And really, I'd like it just to sweep all the way around. Let me double check and see if that's actually the case and see if it's what it's doing. Yeah, so see how it's sweeping down? You may not have saw that, it was going quick. There should be a setting in here that allows me to do that. Bear with me 1 second. Then again, do I really care all that much? As long as we have some overlap in the bottom, I guess it doesn't really matter. You know what I mean? Like I don't want to leave like a feed mark in the middle. So if you look in the bottom here on overlap, we could set an overlap distance here so that it doesn't leave like a spot on the bottom of the grooves. Oh, I forget how wide is this sucker, so we don't make a huge overlap. 370. Okay. 270. So let's just set an overlap distance of like 0.05 on the bottom, and then I'll be fine with that. So I'm going clockwise. I'm only doing one pass. Finish step over. We're only doing the one pass, and it's less than 100,000, so it doesn't matter what the step over is. And then we have the middle overlap of 50,000. Okay, I'm good with that. So we'll click OK. We'll regen that. And then I just want to confirm that that overlap is doing what I think it is. So when it gets down to the bottom, it should go, that the center of the tool should be going past the midpoint of this line by that 10 thousandths that we selected or whatever it was. And we care about the middle point of this because that's where the cutting action is happening, right? So, and it should be calculating it based off that. And see, it didn't do it.
When it comes back to another sweeps around the whole thing.
It does. Ah, okay. Okay, that's fine then. There it is. So what do I have to do to eliminate that first part? I wonder if the step over is causing that. Although I think you have to have something in there. I don't think it's going to let us just do 0. That's exactly what I want right there. That's all I want. I don't want the rest of that garbage. Direction for first pass. But there's no option to turn off the first pass. And there's nothing in roughing that'll let us do that. Actually, is that what I'm thinking of? If I turn roughing on and I change this from, tell you what, I'm going to turn off finish for a second. So here's something too. So, you know, doing groove rough and groove finish, it doesn't, you can use the roughing command to finish, right? So if I'm looking in roughing, this seems to have more like what I want, what I'm looking for. And if that's the case, don't be afraid to use this, right? So let's just say I only want to do that one pass. I want a nice smooth transition, and I don't want it doing that first cut, you know? So if I say I want a positive break, I want to come in the back and just do this all at once. Let me see if this is the tool path that I want to actually see. Oh, no, I need to change it to, maybe that's why. Oh, no, I can change, instead of groove, I'll go to smooth instead. No, it's still going to chop. That's probably why we don't want to use that. Because instead of doing the finish path follows the chain, but the roughing path only does that. I don't want that either. Okay. All right, so we'll stick with what the finish path gave us before. I'm okay with that. I'll walk through the whole thing again. So you had the chain, right?
Yeah, I think so. It just looks like I'm coming in and out.
Okay. So inside of the parameters, you have grooving, you have the roughing turned off. In finish parameters, the finish step over doesn't matter because we're cutting less than 100 thou, but it's 0.1 by default. Oh, okay. So if you turn that off, just go ahead and just use the finishing, and that's it. Okay. And then just put the 50,000th overlap in the bottom, although it doesn't really matter because the second pass does exactly what we want. So that dynamic tool path was the main thing. That was the first one that I want to review with you that's new. If the chaining was not as difficult, you know, let's say that worked at first, we'd be done with this part by now almost. It's a quick command. It's a good way to remove a lot of material quickly. And it's more efficient than it would have been to just come in here and use that other roughing tool that we look at and just plunging up and down. You know, by sweeping back and forth like that, you can run at a higher RPM and a higher feed rate, and you just tear material out of there real quick. So with that lathe groove completed, we can save this. And now we're going to do some C-axis stuff. And again, hopefully the chaining is not going to cause us an issue. I'm going to hide all my previous tool paths, right? So it's easier to see. And I'm going to go back into levels, and I'm going to turn back my solid on, assuming that we can use the solid, okay? Hopefully we can. So the first thing that we're going to do, let me regenerate all the stuff on my other file here that I did before. Just 1 second here. Okay, sure. Yeah, go for it. Okay. I won't go too far without him, but so the first thing that we're going to do is we're going to machine the flaps. Okay. Now it's very similar to what we did last week. However, it's a different command. So I believe last time we did like that face contour. The one that we're going to do is called C-axis cross contour. Now the difference is the tool was in line with the axis last time we did this, like we were doing flats, and the tool was the same in the same plane as the axis. C-axis contour means we're going to be perpendicular to it. So if our lathe axis is this, our tool is actually going to come in like this, perpendicular to it. Okay. So because of that, that's going to allow us to basically chain the flat part of this groove versus what we did last week is what we used the lines, like the end of the lines for that. You remember picking those? So when he comes back in here, we'll walk through that, we'll chain it, and we'll machine that flat. And actually, it looks like we're going to do something a little bit different. 1/4. Okay. So I was just telling them, so the difference with this C-axis contour is that the tool is going to be perpendicular to the axis this time instead of parallel to the axis like last week. It's a different command, but it's the same style stuff. So the way this is set up for us is we're going to cross cut this with a 1/4 inch end mill. And it's actually going to be size to size with the feature. So the distance between this side wall of the pulley and this side wall of the pulley is a 1/4 inch. So we're basically just going to run a 1/4 inch end mill straight through this thing to get the flat. The way that we have it chained in the completed tutorial, and it makes it really easy, is that we're going to draw a line straight across that the end mill is going to follow. So instead of chaining the solid, we're going to chain a single line going across that. So that way, and that's actually pretty good because that means it won't screw up. It doesn't matter what our solid looks like. So I'm going to make a new level. With the add a new level button. We're going to name this level, let's name it the groove milling tool path, something like that. And we're basically going to draw 2 lines, one each across, using the center points that we can get here. So I have my number 4 active, that's the one I just made. I'm going to just position my model so that I can get a good view of the area I'm going to draw the line on. I want to select line endpoints in wireframe. And I can snap right to the middle of that flat. You see that? It's basically in line with the center of the hole. We can grab the top, the middle part of that line, drag down, and get the corresponding endpoint on the other side. So that's our first one. Now we're gonna zoom out and rotate to the next side, the next flat, and do the same thing on that other side. So I'm gonna snap to the middle point of that line and then snap to the opposite end. So that's basically gonna be the center line of our tool for our C-axis cross contour, okay? The reason why that is probably being done is because of that hole in the middle. So if you remember what happens when you grab a surface like this with milling, for example, it'll see the hole in the chamfered edge, and it will try to ignore it, like it'll try to mill around it and not over it. So unless you use an end mill that's as small as this distance here, the tool path won't even generate. If you do pick a tiny, tiny end mill and you had selected this area in here, it would basically just machine the outside area and not do where the hole is. So that's why we're doing this just bypass here. So again, we want to do C-axis cross contour. So if we go into lathe, it's still inside of turning. We look at C-axis, and it's the third one from the right. So cross contour. We're going to change our chaining mode to C-plane and wireframe. And now we can just click those two lines that we drew at the same time. We want independent chains. So we'll see. Oh, let me make sure I'm in the right plane. I may not be. I wasn't. So you see how my D plus Z plus wasn't active? If yours isn't either, make sure it is. So plus D plus Z, the WCS should be on that plane. I screwed up and didn't check that first. Once I've confirmed that that's active, now I'll go back and do the turning cross contour again. Now I'm going to click on that line, and I don't get the error that time, which is good. So I have a green and red arrow on that first line. Like I said, I want to have two separate chains. So just to do it this way, I'm going to click OK. Oh no, it didn't work, right? No, because it drops you back into the contour box. I'm going to go back into chain geometry, just try to pick that second one. Oh no, this will work. So now that I'm back in the chain manager, I can right click and do add. And then I can get the second one. So that means you're in the wrong plane. So go back into your plane tab in the bottom left-hand corner and make sure your D plus Z plus is the active one. It probably isn't. Oh, let's check it. Okay, yeah, so just double check it, and then go on. Okay, yeah, now you're. Pully, it shouldn't matter. Yeah. So now go back and select it. So go ahead and redraw.
right, I'll go back over to the front. Shouldn't have. You did that, you did the error, or you got to do it, right?
Yeah, one thing that I don't know, they were supposed to be pointing in the same direction.
It doesn't really matter, we may play with it later, but it will matter with how it comes in. But for now, we can do the same work.
So, all right. That's real. Yeah, that was. All right, so, okay. So. Yeah. Right. I'll go back. Yeah, that's right. I don't know why. Okay, take the other side. That's not good. I don't know. Oh, it's up to Mark. I don't think it's gonna mess you up at all, but we'll do that. So now you'll be going back into parameters. Okay. So, the direction, you know, the way this looks right now is that when the ML comes across, it's going to go back and coming from the same direction. Maybe it might be a little bit cleaner to go like one way this way and then back the opposite way on the other side. But we'll see what it comes out as, and then we can tweak it. So again, this is a 1/4 inch. So after we have the chain, we're going to go into tool and find a 1/4 inch end mill. Hopefully we'll have that right in the library. Doesn't look like we do, so we'll have to go find a 1/4 inch end mill, which is not a big deal. Probably going to go look in live tooling. So I'll click on the new library. We'll check out the SDCC live tooling library, see what we got in there. And yeah, so we've got, it looks like we've got a 1/4 inch finish end mill at the minimum, but I'm going to sort by diameter and see what we got in here. So it looks like we just have 3 options for finish end mill call outs. Yeah, and they're all 2 flutes. I mean, that's not a big deal really, because we're not taking that much material off. So I'm just going to grab tool number 3 out of that live tooling library. 1/4 inch finish end mill, 3/4 long, that should be plenty. So tool number 3, our comment is going to be to finish the groove at the bottom. Finish the flat in the bottom of the groove, something like that. We're not going to leave any material for finishing or anything like that. I do not believe, although it looks like I need to take that back because it does actually look like we're going to do a finish pass on this. Yeah, so we leave 5 south for finish and then we do it again at the end. So that's fine. We do this twice. So I'm just gonna say rough instead. So rough the flat. Rough the flat in the bottom of the grooves, and we're gonna leave 5 for finish.
So everything else is going to look similar, right? So cut parameters. There's no compensation because we're using the tool to basically create the geometry, right? So it's just gonna follow a line, and it's just gonna, the size is gonna be whatever the tool size is. We're gonna leave 5 thou on the floor. That's gonna be what we're gonna finish. We probably should specify that in the note. So leave 5 thousandths for finish on the floor. No depth cut. Our lead in and lead out, if we leave it turned off, it's just going to come straight in and out. Now, remember from last week when we had to extend the contours to get this to cut properly because the geometry kind of ends weirdly? We had the same issue here, right? Because we're stopping a little bit shorter than we should be. If we stop here, we're not going to finish we're not going to fully cut this contour. So we're going to turn our lead and lead out on. I'm not as worried about like the entry and exit stuff, but I do want to adjust the start and end of the contour. So I'm going to turn those two boxes on. And we could do the math on this, but I'll just tell you the values. So in order to get that to fully clean 100%, we need to extend those by 0.125 or 1/8 of an inch. So make sure you put 0.125 in the right-hand box and not in the percentage box. And then you need to change the radio buttons to extend rather than shorten. So that's basically just going to make it so that the end mill goes out a little bit of 1/8 of an inch farther than what the line is that we drew. So for linking parameters, we're all going to be in absolute again. And then this is where it gets a little fun. So let's look at the blueprint. So our clearance is going to be from the axis. All right, so our minimum clearance amount would be like 0.6 because the diameter of this thing is 1.2. You see that on the print, okay? So the clearance is going to be half of what, we're looking at half of that amount because we're only working from the top, right, from the axis. So if we put in a clearance of 0.7, what that actually means is the clearance is 100 thousandths above the top of that part. Does everybody follow me with that? Everybody's okay? These are all from the axis. So we're also going to say the retract is also 0.7 because we're going to be pulling out above the part before we want this thing to start rotating and going to the other side. So our retract is the same as our clearance. On the retract, yes, I believe you could. Yes, yeah, you could. It just gets complicated when you start using that. I think that's what we try to stay in absolute most of the time, I think. We'll try it both ways if you want to check it out and see what it does. The feed plane is, again, based off the center of that. So if we look at the print again, the thickness of those flats is 300. So our feed plane could be as low as 1.15. That's right where we start cutting. That's not where we want the feed plane to be though. So the values in the completed file are 0.275. So that's what we can go with. But I just want you to understand these numbers. So 0.275 means that the feed plane is 0.175 above the top of where we start to cut, or roughly 1/8 of an inch over the top of that flat. Okay. We're going to say top of stock is the same, even though it's really not, because, well, actually 2.7, that's true. So we left material at the bottom with that grooving tool, right? So that 275 number is there because we have extra material there already, right? Because we did, when we oh no, we finished it though, right? No, we finished that though. The 40,000 that we left on the bottom, we took that off with the finish tool.
Yeah.
So there really isn't anything extra down at the bottom right now. But we'll go 275 again for top of stock, and we'll watch how this works. As long as you remember that all these values are based off of the axis, then you got a handle on it. You just got to kind of stare at it for a few seconds to wrap your mind around it. And then this 0.15 depth value, again, coming from the axis, that makes sense, right? So if this feature is 0.300 thick, that means 0.15 depth is good, because you're going to be adding 0.15 and 0.15 together to get 300. With that, I believe we should be all set. So the only thing that we're going to check now when we click OK is we just want to see how the end mill reacts. And it looks like we're going to have to change the lead in and lead out a little bit, because I think it's cutting into the sidewall either at the beginning or, okay, so it's at the beginning. So I think what that is that's the radius of our lead in. When it gets down to the bottom, you're going to see it kind of arc in. Yeah, you see that? So we just need to change that lead in and lead out so it comes in straight instead of coming from the side. That's all. As far as everything else goes, that cut looks pretty good. The depth is good, right? So there's that bad lead in and lead out again. And then we'll watch and see how it moves to the next end. Okay, that's not good either. Yeah. All right, so let's go look at the lead in and lead out. Should be easy enough to fix. So instead of perpendicular, we'll go to tangent. So you see the difference of the graphic when you go from tangent to perpendicular? So tangent comes straight in at basically at your chain versus from the side. So both our entry and exit should be tangent. Okay, it's going to come in and out. And then we have a pretty giant radius there. Let's change the radius to let's just do 20%. So if we do 20%, what is that? 0.05. There you go. So we're basically reducing the amount of travel, right? So it's not gonna have this giant sweeping arc. It's just gonna come in real quick and just do a little sweep in. So lead in, lead out, entry, tangent 20%, exit, tangent 20%. And then the major change here is going to be the tangent. So we'll check that out. I'm going to click OK and regenerate. And that makes a huge difference, right? So here's our 0.7 clearance, which is great. I'm going to run that. So now it's coming straight down. It's coming inside the groove, but it's off the material. You see that? So it's coming down all the way. It's barely off the material, but I'm okay with that. Now it comes in and sweeps. Because it's tangent to that line, it should pull straight up, yep, without arcing into the sidewall. And now we just got to watch this motion. So think about what happens. The tool's going to pull out, and what's going to actually happen is, yeah, see that? That's not good. I feel like it should be rotating around it. Let me check. Because what's actually happening here is the part's going to rotate in the lathe. You know what I mean? The end mill is not going to do that. Well, I guess it's the same thing.
You go into art and the suite is 90 degrees, got the painting stuff,
Yeah.
come straight down, go straight through, and do the same thing I did. This is straight backwards and then push it off.
So if you change the, sorry, let me go back in here again so I can understand that. So you got,
But it's the suite,
okay, yeah,
put it at 90,
and that stops it from,
not the radius. Radius is at 0, the suite is 90.
oh, sorry, okay. And you do that in exit, entry and exit? Because basically what you want, I mean, really what I want to see is technically, so you machine this, the end mill goes back up to the same clearance point,
Yeah.
and the part's going to rotate. Yeah, so that's what but you don't see that in Mastercam, so it's kind of confusing, right? The part doesn't actually rotate. Yeah, so it still flips over and does that. It's also doing that same motion in the other one.
How do you change it? With one of them.
Did it work better?
Both making the same way.
Yeah.
So the spirit is, it'll cut and it'll come straight up and then it'll go to the other side, comes down and then go back up.
Okay. Okay. I'm fine with the way it is. I believe the back plot is not. Actually, you know what? Let's verify it. Because I think the verify actually will do that correctly. This may be a case where the back plot's actually inferior to the verify. So if I go in here and do a color loop and play this. Yeah, see, so the verify actually shows it correctly, right? It skipped past it, but if you look at this, it's not blowing it out. Now, I've got an issue here for some reason, but I can check that out later. What I'm seeing on the C-axis looks good though, so I'm not going to worry about. I'll look at the other stuff later. So I guess in this case we're better off looking at the verify. And if I do the same thing in the day class file, yeah, thank you. Okay. Good. So that's a C-axis contour. So go ahead and verify it if you want and make sure you're getting it. You know, but obviously in the verify, it's not ripping that whole thing off the way it looks in backplot. So I'm happy with that. We can post the code to this and take a peek at it too, and see if it actually. Because I imagine both those cuts should basically have the same exact code. Really, it's going to have an M whatever for the part rotation. It's going to rotate the part 180, but then everything else should be the same. So you all had that same crash too on that sidewall, huh?
Yeah.
That's the grooving tool. We can probably fix that later. We'll take a look at it. We didn't backplot in between, so we didn't catch it, but we'll fix it. So now what we want to do is we want to do that same C-axis contour, but we want to do that 5,000 cut, right? So that's as simple as duplicating the toolpath that we just did. Everybody should know how to do that now too. I'm basically just going to hide my toolpath. I'm going to highlight number 8, so that's the only one that's selected. Make sure only number 8 is got a green check box, because otherwise you'll copy everything. I'm going to right click, copy, and I'm going to right click in the red insert flag on the bottom and hit paste. So then we have a toolpath number 9, and all we're going to do is go in there and delete that 5,000 out of the cut parameters. So we're going to do that 5,000 cut on the floor and get rid of that. Now, the reason we're doing that is because I believe either trying to think what goes in there. They want the floor of that perfectly flat, either because a bolt head sits on that or a washer, or there's something that sits in there. So that's why we're taking the 5/10 finish cut, because we want that to be a nice surface area or a nice finish spot. So once you delete the 5/1000 out of the floors, you can click OK, and then you have to regenerate it. But it's going to look exactly the same as the previous toolpath for the most part. And then we're going to save. Basically, what I want to do next is get through the drilling and the cutoff, and then we'll do the stock flip, and then you'll have the rest for homework, it looks like, because we're getting closer to the end here. So, and you know, after the stock flip, the rest of the stuff in back is easy. You're just copying the same stuff we've already done. Okay. So after you saved it, the next thing we're going to do is the drilling, and this is simple. Should be simple anyway. There's not much to it. It's a 7/64 drill straight through. We'll confirm that on the blueprint again. 0.109, and we can look at our chart. So 0.109, just to confirm, 7/64, 0.1094. Excellent. So due to the geometry of this, I don't think it's reasonable to center drill it. You see what I'm getting at here? So there is no center drill in the example from the day class, and you see the height on this? It's because there really isn't any point. Any center drill that's that long, it's going to have the same kind of wobble characteristics as a drill at that point. You know, you're not going to have one that's 700 thousandths long. At least you wouldn't have one that long in a standard toolkit. So all we're going to do is basically peck drill this through. Okay. It probably also means that the straightness of that hole isn't as critical, because the only other option we'd have is we could plunge mill this with like an end mill, a center cutting end mill. We needed to have a really nice straight hole all the way through. But all we're going to do is just basically cut through with a regular drill. We're going to use C-axis cross drill for this. Okay. And again, there's two drilling options, and it's the same as last week. So a cross drill would be parallel. The axis parallel with the axis. So if you're drilling in the side face, like a bolt pattern side face. C-axis drill is when you're perpendicular to the axis. So anything in here that says C-axis whatever means you're perpendicular. Everything else means you're parallel. That's it. So in this case, we're drilling perpendicular. So we're going to want to select C-axis cross drill or C-axis drill. We're just going to decide, we're just going to pick one side. This doesn't really matter which side. We want to get the center of the hole. We're only selecting one end because we're just going to drill straight through it. So I have my center point. I'm going to click OK. Obviously, there's a chamfer on that. And we're not going to be forming that chamfer simply by drilling this. So even though it's drawn with a chamfer, we wouldn't actually have that the way the file is going to be right now. We can look at that and see if we can figure out a way to do it next. So C-axis drill, we're going to go to tool, and now we got to find a drill. So we're looking for 7/64. I don't know if we're going to have that in this live tooling. Let's check it out. I'm going to use the filter because there's a lot of weird stuff in here. So in the filter, I'm going to click on none to clear all that out. And then drill is on the second row, fits from the left. I'm not going to put a diameter in. I don't like to do that. I just want the drills. And then I'll click on the diameter filter in here to get to filter by size from smallest to largest. So 0.0194 is tool number 100 in the Stick Live Tooling database. Matt, you may have to go digging around in the Big Mill database maybe to get that drill size.
Okay.
I really should just send you this freaking tool library too. I keep saying I'm going to do it, I never do. I'll do it tonight before I leave. Since I still have my email open, I'll just send this live tooling database right to you at home.
That'd be great. Thank you.
Yeah. So I'll click OK here. Our comment, we're still in the live tooling database. You shouldn't have to switch because we were already in it from the previous op. Yes, that's correct. It looks kind of weird, right? Because because you know what? Don't go by the tool number, I guess, because there's tons of duplicates in here. You see that? Now I know why you're confused. Sort it by diameter, and then you'll find it 0.109. There's more than one tool number 100, which is terrible. That's not good. Yeah, okay. Oops. I duplicated it. Okay, so our note is going to be PEC drill through. We can put a Z minus number in here later. It's going to be negative, probably 200 or something like that at the end, but we'll figure it out when we get to it. So cut parameters are going to be PEC drill. And again, I usually do like a half of the drill size. So if we do 0.109 divided by 2, our PEC can be like 0.05, 0.06. 0.06 is a nice number because that's a 16th. So 0.01, 0.063 be good. So we'll PEC every 16th. And then our linking parameters, again, are based off of the axis, okay? So we got to use the same kind of numbers we were talking about before. So a clearance, all our numbers are absolute again. So clearance 0.7, same as before. Retract 0.7, same as before. Our top of stock can now be the bottom of that flat, now that it's machined. So our top of stock could be 0.15. Now, the interesting part about this is it may depend on which side of the drill you selected.
Yeah, that's negative side.
Okay, okay. So let's try the negative side first. So let's go negative 0.15. Oh, it didn't work?
Yeah.
Oh, okay, all right. So we may need to swap it out again. So let's go top of stock, negative 0.15. In our depth. Let's click on our depth. So actually, let's just click on both, right? So I know which one I picked on. So I'm going to select my top of stock button. You're going to let me pick it as the top of the one I selected. And I'm going to go and do my depth. And I'm going to do the depth at the opposite end. So in my case, it was positive 15 and negative 15. So positive 15 for top of stock and negative 15 for depth.
I think it's 0, 15.
When you click on it?
Yeah.
You may not be in the right plane. Double check and make sure you're in D+, D+. Did it get switched?
Yeah.
Okay, okay. Now this may be a little funky, we'll see. I'm turning tip comp on to, and I'm going to change this, I'm going to put a breakthrough of like, I don't know, 20,000. Now let's do more than that. Let's just do a breakthrough amount of 1. There should be plenty of links in that drill. Now let's see if that is correct. Invalid rotary diameter. Rotary diameter cannot equal 0. But we're not doing it from both sides. Why are we in axis substitution? Yeah, I get that. Ooh, that's a nasty error. Why don't let me click out of the damn box? I'm just gonna put a value in here just to get out of this, and then see what the hell is going on. Oh wow, it's really broken. All right, hang on a minute. The axis thing should not even be a problem because we're not cutting from both ends. You know what I mean? So let me look. Oh, there may be some planes here that we got to screw around with. Yeah, we may need to do a plane. Hang on one second. Let me look and see. So in the C-axis drill, the work coordinate system is DZ, but we got upper left for the tool plane and the construction plane, which is similar to what we had to do on your file over there earlier when we were doing that. We split it up a little bit. Let me investigate this for a second.
This is on the main framework.
I don't like this because it won't even let me change anything now. It's almost like I have to delete this and redo the whole thing.
Shaded box and not access control, the rotation type and selection for no rotation, but.
It's grayed out, right? Yes, correct. Oh, I got screwed up here. Look at that. It should be cross drill. That's why. So C-axis drill. Okay, now I'm confused. C-axis drill is perpendicular. C-axis contour is wrapping around. Okay, so it's not the same. So we want the cross drill. So that's drill holes perpendicular to the part's spindle axis. Let me try the drill. Let me try the other one. I'm going to get rid of the C-axis drill. Let me do the cross drill and see if that's what we want. Just bear with me 1 second. I think I screwed that up when I was talking to you guys. The good part is all this stuff is still going to be in here. So we just PEC drill 0.063, linking. So again, I'm just going to put 0.7, 0.7, and then I'm going to click to make sure I get the right steps and stuff. So now you're right. My stuff comes back to 0. So that means I screwed up on my planes. But these are the right planes now. What happens when I click OK and drill this thing? So it's pecking from 0.17. Oh, my battery's dying, Matt, so I may lose you, by the way. We're running out of time, Sue. But all right, so we're pecking from the 0.7. So I don't like that, so we can change that. But go ahead and, so if you haven't done it yet, go ahead and delete that first one that we just did, the C-axis drill, and do a cross drill instead. That's my fault. So inside of the cross drill, like I said, so you're gonna pick that tool, so the 7/64, and the comment is gonna be drill through the part. That's fine. Drill through the part. So your cut parameter should be a PEC drill of 0.063, give or take. I round it up to a fractional size just for the hell of it. So the linking parameters that I have, so clearance of 0.7, the retract of 0.7. It may have to be that way because it goes back to retract when it rotates. But well, we're not rotating, so the retract can be lower than 0.7. I would actually maybe do that at I don't know, 0.25, something like that. We'll see what that looks like. I don't like that the depth and top of stock are 0 though. And then turn your tip comp on and break through 100,000. We may have to revisit this next week. That retract looks better.
So incremental for depth, you get about
What's it give you? Does it give you the 0.15?
54,000.
I think we need a plane here. I almost want to make one on the top of the hole here, but I don't think we need to. We're going to need, I can't go. I mean, what happens if I just hand type this in rather than clicking on that? Maybe that's part of the problem. So if we go back to our regular parameters and we just do a top of stock of negative 0.15 like we did last time, and then positive 0.15. Let me just see what that does. Looks to be about the same actually as the 0. No, not at all. Interesting.
Like maybe goes to halfway.
I think it's going farther than half, or is it going to 0? It's just going to half and that's it and it's stopping.
Goes down a little farther.
That's probably the breakthrough amount. Negative 0.15. This is supposed to be the easy one.
Well, it is,
I got almost through that.
Oh, I think I got it. So 0 is the center of the part, right? So 0 is the axis. So if you go negative 1.5 in your depth, it's going to go past negative 1.5, and then you have your breakthrough. I don't know why top of stock is negative. Maybe do positive 0.15 for top of stock.
Well, yeah, it's 150 for top and negative 150 for depth.
Yep. And that appears to, yep.
Breakthrough at 150.
Yep. There you go. Sorry, I was getting screwed up too. Yeah. So we're going down. So you can't click on the solid because it gets confused. You have to type it. But again, so you think about it logically. So the axis is 0. So negative 150 is your minimum depth. So you go a little bit more with the breakthrough. That all makes sense. Excellent. Okay. I'm going to, well, let's keep going. We're almost done. So I want to make sure we do the breakthrough. We want to do the cutoff, and then I want to do the stock flip before you leave because that can be kind of confusing. So I'm going to look at my view from the front again. All right. I'm going to save all this. I want to make sure my plane is still Z plus Z plus, which mine wasn't. So go back and make sure you have that plus Z plus Z. I'm going to try and go through this quick because I'll post the video. So if you don't get this done entirely right now, you can watch it when you get home. But I want to make sure we get that stock flip done. So we're going to go to cutoff. I'm going to select the back of the part. Doesn't matter where because we're going to use it from stock. So it's going to figure out where we are for our stock. I'm going to go into the library. We don't have any cutoff tools in the live tooling. So I got to go back into the regular like ST20 tool database, most likely. And then that's going to have a cutoff. Let's see, we could just grab T131, that's an OD. Looks like T0909 is an OD cutoff, so we'll take that one. T0909. Comment's going to be cut off apart. Remembering from last week, we want to go into stock update right away and tell it that we're going to keep the separated piece for our stock flip later on. I believe that's the correct one we want. Cutoff parameters will be from stock. Entry amount of 100 is fine. We're going to go from stock for the retract radius. I'm not going to leave anything on the back because that screwed us up last time. I don't really care that much. We can do that chamfer, I guess. So in the corner geometry, I'm going to change it to chamfer. It looks like we just type in what we do here. So inside of parameters, the parameters button next to chamfer. The width is 0.01. Oops, I did that. The angle is 45 degrees. And then it's just gonna give a raise on the top and bottom with 3 thou, just to make it not sharp. So that's fine. So that should match what's on the print, I imagine. I'm not sure it calls out. It calls out 0.05 by 45. Basically, yeah, I believe so. I've never done this one on this command here. I'm going by what is in the example file. And then clearance cut. It's turned on, but none of these values are changed. So let's see what that does. The corner geometry, like I said, I'm not super worried about it. I'm just trying to match it. Let's see what it looks like. So I'll click OK. And then we will hit the play button. And it looked like it did something bad, actually. I don't know what. Okay. Yeah, I don't like, just turn off that chamfer, that corner geometry thing. Just turn that off. It's doing more harm than good. None for now. And get rid of the clearance cut too. I just want to see if we get that straight piece on the back. See that? That's fine. I don't want to mess around with that until I actually figure out what the hell that does. So this just comes straight down. Again, we're not leaving anything on the back. And then it keeps the piece that we cut off. So when we're out of back plot, we see that remaining little cube in the back that we got to machine. And that's what we want. Again, I'm going to rip through this real quick. So I'm going to say that now we're on to an op 20. Okay. So I'm going to right click on machine group and make a new toolpath group. So this is going to be op 20. And actually we should put I haven't been doing this. We usually call out the G. I mean the name of the WCS. So we're gonna have a new WCS on this at the end too, G55. The one prior to this was G54. If we want to rename that one now real quick while we're thinking about it. And all I want to do is get this stock flip done. So the stock flip is inside a lathe turning. It's like a tool path under part handling. So inside a stock flip, same kind of stuff we did last week. All right. So in geometry, we're going to select the part. I don't want to blank the original geometry. I don't normally do that. So we're going to uncheck that. we're going to offset the level by 10 again. It's going to make a duplicate part, right? The same as last week. Our stock position and transfer position, I'm going to leave those alone. Now, our chuck position is going to be, it should be the 4. Ooh, this is going to screw me up now. Let me just try it. So if I do the negative 4.0 and Z negative 4.0 here, let me just see if this does it correctly. Yeah, because now the WCS is on the back of the part. If I turn off my level for the first one, and that's good. Okay, so there's our parameters. So I'm going to go back in and let you guys finish this off. So if you're inside a lathe stock flip, it is inside of lathe turning, and then it's about halfway through the side of the screen under part handling, the part handling subgroup. So active spindle left, the geometry you hit select, and you grab the part. You're going to uncheck blank geometry because we don't want to delete the original. In level options, you're going to just offset that by a number. It's going to create a new level for you. So if you do offset 10, it's going to create a level 10 units away from your newest one. Your stock position you leave alone, but for your chuck position, you're going to change that to a D of 1.5 and a Z of -4 for both original and final. And when you flip this over, it's basically rotating the whole thing 90 degrees so that the G54 ends up on the back of the part. And then for homework, you can just finish the machining on that side. So you're going to do the roughing and the finishing and the threading again. And you'll be all done. So when you click OK and you turn off the levels associated with op 10, your part's going to look like this. So you're going to see your stock is going to be on the front half of the part now.
So you for 100,000. That's the 2 diagram.
Good question. Oh no, because good question. Yeah, no, you're right. Yes, I think you're right. Because if we look at the chuck the way it is now, it's probably open too big. It's hard to tell from here, but yeah. So look at this. You see this? If you take your mouse and come over this way, yeah, it's too high. You're right. So we can go back in there and change that. So if we change that to 1.2, oh no, original is 1.5, final is 1.2. Thank you. You should see that squeeze down now. Yep. And actually, the position of a chuck's not right either. We'd actually want to move that in so that we're grasping on probably the flange here. So I don't know what that does. Like if I change Z to 0 for final position, where does that put me? Probably pretty damn good actually, but I don't know why 0 would do that. But I mean, actually, that's pretty much that. I mean, that's a pretty good grip right there. I mean, I think that's not bad. We're not finishing anything up past that flange. So if you have if you put final position Z0, I'm not going to argue with that. I like it. I'll let you guys kind of come up with a solution that you like at home. As long as you have the stock on the opposite side there, when you leave here, you're in good shape. So does everybody have the stock on the opposite side? You don't? Okay.
So click OK. Let me see what it's on. All right, so go back in the frame. Windows regenerated. That.
And then, can't find that.
Okay.
I'll get it in the right spot.
Go back into the cutout. Oh, I know what, yeah, you can open that up. Get it going with transfers.
That one on.
And you want to go back into now your sensor. Go into stock up. And we want to keep it separate. So it was keeping the long part over here. You wouldn't want. So when you regenerate that. So there's a small part, and now when you drag it, it's just like that. Down. And oh, don't make me worry. Oh, uncheck blank. Now we're going to offset by 10 and make this save this. Now this is going to flip to do that. So this one gets turned off. So I think you didn't have the file selected, and it won't let you pick geometry once you exit out. So that's what we're finding. So there's the one. And then so you can say that, and I can just remember that. Oh, you're welcome. Sorry, I had to rush through that, but we're running out of time a little bit.
I wanted to figure it out.
Yes, okay. Hey, Matt, how are you doing? Did you get through to the stock flip?
Yeah, I've done the stock flip. Yes.
Okay, so you're basically you have stock left on the screen similar to what I have.
Yes.
Okay, perfect. So if you've got that, you should be able to complete the rest of this, but because you're pretty much just going to copy the rough and the finish commands and the threading on the back end here, and then you'll be all
Right.
set.
Sounds good, Sean.
Now,
have a good night.
Hey, you too. Thanks a lot. Well,
All right. Take care.
You too. One thing I do want to mention is the chain. You may have to break the chain again. Okay, because if you go to select this, you don't want to machine up past the sidewall here for roughing and finishing. So you may have to make another wireframe and then break at the top. Just keep that in mind when you go to do this, okay?
So break it at like the very, at like the top.
Basically, like up by the radius here.
Right here.
Yeah, yeah, yeah,
So it just goes straight up.
exactly, yeah, yeah.
I'm just guessing. I'm not entirely sure, but I'm just thinking ahead. I think you might have to. And so I'm going to save this. I'm going to end the recording.